Hi guys. So let's continue from the use case number 3 of Hive additional use cases, where I have left up to use case number 2 yesterday. Okay. So we are going to deal about the fixed with data. So this is something specific type of data we may be receiving from some of the systems, right? Especially from the mainframes kind of systems where they'll be using more of the fixed with data. They used to use episodic data or fixed with data kind of data. So what is a fixed with data is all about, right? And we are going to learn one more schema migration operation that we are going to do. So how do we convert the data from a fixed with to the comma separated or some other data set is the concept we are going to see over here. For example, the requirement is like this. Source provider is providing unstructured data. The fixed with data is naturally an unstructured data, or we can get the unstructured data in a fixed with format as well, or the data which is not having any delimiter. Rather, we have to go by the position. We have to go by the length of the data that we have. Okay, so basically, the fixed with data looks like an unstructured data, or an unstructured data can be sent in a fixed with format, or even a structured data can also be sent in a fixed with format without any delimiter in it. Okay, so we have to load the subset of the data into the table, maybe into the RDBMS or into the Hive table or wherever, and then we have to load it into RDBMS in the sense the normal Hive table, and then we have to load that into a JSON table, then we have to load it into an ORC table. That is our requirement, what we have with respect to this fixed with data management. So by splitting the columns from the given fixed with data, we have to load the data into the target table. That is the requirement. So basically, how do we handle the fixed with data is by using the string data type or the varchar data type predominantly. That is the key idea behind how do we handle the fixed with data. For example, if you see, this is the data we are going to receive from the source, which is structured in nature here, but in a fixed width format. We don't have any delimiter to delimit the fields. Rather, we have to use the width of the column to delimit the data. For example, if you see here, this is how the data looks like. So for example, the first 3 characters is going to be our ID of the customer. Then the next 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe 12 characters are going to be the the name of the customer. If you see here what I mentioned, then from the 13th character or after 12th, we are having the city, which is around 3, 3, 6, 7, 8, 9, 10 characters. So like we are going to already predefined with this length of the data provided by the source system, which may be having the length up to whatever the given value. For example, the name has to be up to 12 characters only. It should not be more than that. After 12th character, we are going to start with the city. City may have up to 10 characters. So maximum length of the city they will consider for forming a single field actually. So by that way, they are going to provide the data in this way by mentioning what is the length of each and every of this field. For example, the date, if you consider, it has 10 characters, and the amount, if you consider after the 10th character, the rest of the part is amount. Maybe amount has 5 characters or whatever. So totally, if you go and see, this entire characters that we have over here is 43 characters altogether. If you see all the way down, we can see 43 characters of data we will be having in each and every row. So we are going to load this data into the Hive table. How do we load? So create a manage table in a raw zone, right? Or create and load the data into the table by making it as a string type. Then you are going to create a temporary manage table and load all the data into the respective columns by applying the parsing logic. That is nothing but first you are going to create one manage table, load the data as is. Then we are going to create a temporary manage table and we are going to load all the raw data what we loaded in the manage table by applying the substring function kind of thing on top of the data. So we are going to create first of all a manage table with one column, which should have the character length of 43. Varchar of 43 characters, we have to create a table first of all. And we have to create one more table with each and every column name mentioned with the column length of 10 characters mentioned. That is a second temporary table we create. Then we create a temporary external table, because why we are creating all as a temporary, the reason behind the data is not needed in a form of table. Only it is needed in a form of like maybe whatever has been mentioned here, like JSON or ORC kind of format. So we are not keeping this table structure forever. We are going to just get the data alone extracted. So create a temporary external table and insert the insert select only few columns from the temp manage table what we created above, right? Once we complete this, once we close the session, we don't have any other data available other than this only table of whatever the managed table with the fixed with data is available, and the external table, I mean like the few columns that we have selected, right? That data will be available in a Hadoop location. Then from that Hadoop location, we are going to scoop export the data into an from this external table location to a database table. From the temp manage table, load the load the data into the ORC table with some applying some filter. Columns just format, store it into it. So like we are doing what? Loading the data into manage table, then loading the data into a temporary table. In the manage table, it will have only one column. Temporary table will have the respective columns as per the respective size. So we are going to apply the parsing logic to convert this fixed with data to the delimited data. That is going to be happened here. Then that delimited data, we are going to choose only few of the columns and which will be loaded into an external table. From this few of the columns what we extracted, we are going to use scoop export to export those columns to the target table. Then from the above managed table what we created originally, we are going to convert the data into ORC format and store it into another table by applying some filter. From the temp table, again, we are going to take some of the columns and convert it into JSON format, maybe something like the struct type or whatever we are going to apply. This is what altogether we are going to get. So I have some data kept in a location of, in this URL, in this maybe the G drive URL, we have some data available. So I'm going to get it downloaded first of all. The fixed data, if you create, right, you may make some mistakes. So we can make use of this data as our reference. So let's use this data, customer fixed with data. Let's get it downloaded and make use of it. So I'm placing it in our home HD user location. Somewhere here I'm placing this fixed with data. So let's go and load the data into the table. First we create a table with only the char of 43. So the purpose of going with character data type, right? So we are sure every row in this table is going to have the 43 characters length, right? So I'm going to just create a table first of all with char 43 as a column data type and the length, right? Then I'm going to simply load the data, whatever we downloaded from the internet, to this table. So load data local in path, overwrite into table or into table name, right? The data got loaded into this table, which contains a single column with all the data. First fixed draw. So you find this seems to be like a each and every separate column, but actually speaking, all are kept in one column called raw data. We created only one column table and loaded all the data. This is how we have to handle the fixed with data basically. And we have one more option available as well, how to handle fixed with data by using some SERDI called regular expression SERDI. Maybe that one you guys can see it in the project that I have handled in a separate project in the one of the project that I shared you guys. Okay, now I'm going to choose the columns whatever I wanted as ID or maybe like the name and everything by using some substring function. For example, select sub-str of or trim of sub-str of or sub-str of the first the column raw data I'm taking, comma 1, comma 3 I'm taking. This is nothing but as ID I'm taking. So what it will return? We can see this will be returning all the ID values alone of the first 3 characters. You can see here first 3 characters, but I don't really wanted all the 3 characters. Whichever the length it is applicable, I needed only those characters of data. So I'm trimming it. So by this way, what we are getting, only one character of data, rest of the data is not space. We don't have any blank space here. If you see here, we have 2 blank spaces, but whereas here, we don't have any blank space applicable. Directly, we are having this one as an individual value. Like this, we are going to do what? We are going to select the columns by writing some select statement, and we are going to load the data into this new table, something called TMP, EXT, scoop, or whatever the table. But you have to create a temporary external table for that. So create a temporary manager table called something like this, right? So let me show you. Let's create this table first of all. Parser temp or something like this with all these columns, okay, with the respective data type, and load the data from the raw table to this particular table by using substring or whatever the functions, trim, substring, and maybe we can use the cast function also to load the data into the proper data type. So let me do that activity. So create temporary manager table name of all the columns. What are the columns? ID integer, name string, city string. Even we can create it as a varchar also. Since we know the proper size of name and the city and all, we can make it as even varchar of 10 or whatever the size that we had. That is more meaningful, right? So what is the length we got as a from the source mentioning? Length of the name is 12, length of the city is 10. So let's go and mention varchar of 12 for the name. For the city, let's mention it as varchar of 10. Then city, what other column we have? Age column, which is a normal int or small int or tiny int, whatever you can mention. Let it be. I'm making it as an int. Then the date. Date is going to be a date type. And then the amount. Amount is of integer type. Here we don't have it as the decimal or whatever the type. So by this way, I'm creating a temporary table. Create temporary table name of all the columns. Maybe row format delimiter, if you want, you can mention as well. Or that is not needed even. Like this, I'm creating a table. Now I'm going to load the data into the table, right? How can I load the data? Maybe I'm copying this stuffs for your purpose of learning. So we are creating this table, manage temporary table, which is going to only exist until the session exists, right? The scope is only until the session. Okay. So I'm going to select the data into this table by doing what? By selecting the same thing. Select trim of all this as an ID. Like this, I'm going to do what? Select cast of, because this ID is going to be returned as string type. I don't wanted it in a string type. So I'm going to cast it as cast of this entire column as integer, as ID. Then I'm going to cast this column as the second column, or I'm going to trim the second column, which is the name, right? Trim of substr of the name column or the raw column, comma 4 comma how many characters? 12, right? 4 comma 6, 4 to 12 characters. So let's see as name. So you can see the name with all these values. David Hanna, if you see 5, 6, 7, 8, 9, 10, 11. 11 means one more character, since we are trimming, so it won't give unnecessary characters. Now let's take the other column. By this way, we have to first check. Here the casting is not needed because the data type, what it is going to return here, the name is going to be of type string only. So we don't need any casting function. Only for converting from string to integer, string to date, we need the casting function. Otherwise not needed. So again, I'm going to write a query for trimming the or deriving the column called city column over here. City has how many characters? 10 characters from where? From 16th character. So 16 is nothing but first of all we got first 3 characters. 3 plus 12, that is 15. Next to 15, 16. So I'm deriving from 16 the 10 characters. This is nothing but the city column I'm deriving. So you can see the city value that got derived. Then we are going to derive the rest of the columns, maybe age, right? For age, we have to convert it into a whatever the type, right? Whatever the integer type or what we created the table with, right? So age is of integer type, date, and then amount. So age, let me go and copy this enter statement. We have to just change only the position and the column name. That's it. Age, and then date, and then amount. So let's go and derive all of them. Let's derive the age, which is supposed to be taken from the character 16 plus 10, 26, 27 onwards, right? 27 onwards. The age, how much we allocated? 3 characters, I hope so. Age is 3 characters. So 27, 3, 28, 29, 30. Now I'm going to mention the date. I'm going to convert it as a date type. So 27, right? Okay, so 3, 15, 16 to 10, 26, 26, 27 to 3, 30. So 31 onwards, I'm going to start. 31 onwards, I'm going to take 10 characters. That is the date it is going to return. Then 31 to 10, 41. I'm going to start from 41, 41, 42, 43. So 43 characters overall we have. Let's see whether this is returning our expected data or not. I think I'm making some mistake. Let's check. Okay, it's not converting properly. So 16, 10 characters. So 27 onwards, 3 characters. That is age. Okay, guys. So I just stopped in between and just modified these numbers and all accordingly as per the data, right? Without going with the recording because it may take some time for us to maybe like do this, right? So I just now able to do the entire parsing of this data in a proper type with proper values also. So you can see here the amount is being casted as integer, the date has been casted as date, and then we are going to cast the age also as an integer. Maybe let's do the casting of age as an integer. This use case seems to be very simple, but we have to sit and just maybe like perform the operation of identifying all these lengths, and then we can execute. By this way, we will be seeing the result as expected. So age, you can see 43, 55, 33, all this age. And the amount you can see 10,000, 90,000, 20,000. And one value showing as null. The reason behind we don't have the data available at all over here in the data set. So we are good actually now. Now we can go and load this data into the table, right? By going with the insert select. So insert into or CTAS we can do as well. So we are going to load this data, whatever we parsed, that is the next step, right? Create a temporary table with all these fields, and we are going to select the data and load it into this temporary table, into the respective columns, right? We already have the temporary table created. Let's load it into the table, right? Insert into table, select all this column. So by this way, this temporary table, the manage table, what we created is going to have all the parsed columns loaded. So let me go and keep this query also for your reference. You can try this out. Equivalent query I'm placing here for your reference. The create table statement and insertion into the table. Now we are going to create another table called TMP ext scoop because we needed the data what we partially parsed, the intermediately parsed, that data has to be loaded into a Hadoop location by using the external table, which can be maybe like used by the scoop for exporting further. So let's go and query this table once to understand the data is loaded as expected or not. First delimited parsed temp table. So we find the data as we expected. It got loaded properly with the respective data type, what you have created here. So this is the schema migration activity, what we did from the fixed with schema to the delimited data, how we migrate. That is an example what you have seen now. We can create an external table and do the load of some of the columns alone, whatever we wanted from the above table, what we created, the manage table, what we created into an external table location. And we can take this data exported by using some columns option in scoop to load only whatever the data that we wanted into a target table in the database side. So this iteration I don't want to do. You guys can try this. Just we have to do an external table creation and load the data from this managed table what we created above, the temporary managed table what we created above, and load the data into this location by doing an insert select. Then you can go and use scoop export after we come out of Hive. The tables might be dropped, but the location and the data will be available for external table. That's the concept we are understanding here. You can go and export the data by using scoop. That's it. Now we can create an external, maybe like a partitioned, not a temporary table. It's a partitioned ORC table we are creating with all this configuration, right? And we are going to parse to ORC table or whatever we are creating with this configuration, partition based on the date. And we are going to filter the data of only Chennai data from the above, into the above table by selecting the columns from the parsed temp table what we created. So let's go and do the insert into this table from the temp table where city equal to Chennai. Like this, we are going to load the data. This is simply the regular activity of how we finally store the data. We do, right? The same activity we are doing here. So only the Chennai data I'm going to load. That is usual. So wherever I have given you the syntax, I'm putting it in blue. Wherever I asked you to create the syntax, I did not put it in blue. So you have to create it as a syntax. Okay. So create an external table, parse the JSON as well by using the JSON SERD. And you are going to do an insert into the table, right? Insert select into the table from all this table and store it into the JSON format. So we are going to create a table here, the JSON file format. We are going to load the data into this table by doing an insert select. So ultimately, we have to see the data in a JSON format in this underlying location after we loaded. So here we are doing what conversion of the fixed with to delimited data and the delimited data to the JSON data and the delimited data to the ORC data we are converting. That is the exercise what you are doing entirely here in this use case. The schema migration concept. So I'm going to keep this data in this location in a name of maybe like JSON format. So I created a table here. While I load the data to this table, it should be converted into JSON format and stored. So insert into this JSON table. You guys can try that maybe. I'll just write a query here. You guys can try this. Insert into select the columns. Maybe star we can put or okay, only few columns, right? ID, comma, name, comma from this table, the original table what we created. Temporary managed table what we created. The parser table, right? The individual column content table we are going to use to load the data into this above JSON table. By this way, we have to go and see in this underlying location, the JSON data has to be created, which is created from the normal comma separated value table. We are getting the data stored in the JSON table. That's what we achieved here. So another JSON table called complex JSON we are creating, and this table should have the data type such as the miscellaneous info kind of column we are creating, and we are keeping that column of data type city and age together. We are creating a structure type here in this table particularly. So this table is going to help us insert the data in a complex format. So for that, we are going to use the named struct function to convert the data into this miscellaneous info format with city and the age alone taken, and put it in a named structure fashion. And we are going to load the data into this JSON table. By that way, we can get maybe like a complex data types created on the fly. So with this and all, we have already seen in our regular exercise of learning. Try this out and you can provide the solution here. Okay, so by this way, we are done with the third use case, which is all about more of schema migration and management of the fixed with data, delimited data, ORG data, and JSON data, including the complex JSON data we understood here in this use case. And finally, the last use case is all about schema evolution, which is a very interesting and maybe kind of one of the important use case as well, but which may not be applicable always. At times it may be applicable. On and off it may be applicable in our organizations. Okay, so very rare situation, this kind of schema evolution may be applied, right? Which is nothing but the dynamic schema enablement in Hive. We call it as a dynamic schema design or dynamic schema development in Hive. Basically, what does it mean? What is evolution means? If we are going to get something evolved that is going to be keep changed or keep added or keep modified, right? That is called the evolution concept basically. So here we are going to evolve the schema of Hive. Schema means the data, the column name, data type, and the number of columns and all. We are going to get it evolved in Hive naturally, automatically. So that is the concept of schema evolution. For example, very simply say, if the source is going to provide the data to us on a daily basis, maybe using Scoop, using the database tables or using file systems or anything. But one caveat here is usually the source system and the target system will have an agreement saying like, whatever the number of columns that you are defining, right, that you have to follow the same. You should not be adding of your own and all. The new columns are the, you should not be removing the columns, or you should not be change the column order and everything. You should not do that. Like basically we'll get an agreement with the source system. But at times, some of the source system will say, hey, we don't know, like there may be a huge drastic changes may happen in our source formats each and every time when we send the data. We can't able to assure that, like if some source system says, then we have to follow this methodology of managing the data using the schema evolution concept by using the Avro data format. So source provider is going to change the structure of their tables or the data by adding or removing the columns whenever they want. And they are not going to communicate it to our platform team, to our big data team. So how to handle this evolving schema requirement automatically is the question. So it's a pretty interesting question, maybe asked in any way, but the answer is going to be the one what you are going to see here. Answer is going to be very direct. By using the schema evolution concept with the Avro data format, we can able to achieve this. So by using Avro serialized data set sent from the source, we can handle this scenario. Either the source has to send the data in an Avro data file format, or we have to convert the data in an Avro data file format to handle this scenario. For example, we are getting the data from the source like this originally, 1 Irfan 37 or whatever. Then we are going to get this columns added into this table or changed in the order in the table in the source system like this. First they are keeping customer ID name and age, then they're changing the order. Customer ID age and then address they are adding. Address is newly added and the marital status they are adding. Then later they are changing the data type or even the column order, or they're adding or removing some of the columns as well. So in these three data sets, if you see, first day they're sending the data like this, second day like this, third day like this, we could not able to handle this kind of data so easily, right? So in order to handle that, what you are supposed to do, we have to follow some methodology. So this data can be normally handled by a normal tables that we create and all. Okay, normal delimited data or fixed with data or even JSON data could not able to handle this. The reason behind, if we get the data in a JSON format like this, we are good to handle, but we have to sit and understand the data and we have to modify the table to accommodate the new columns. So that we are going one level lower even. and saying like, hey, Hive, you itself understand the list of columns that got added or removed or modified or whatever, and create the table according to that structure, according to the data. Like this, I'm going to ask to Hive to do that work. So for that, what you are supposed to do, ask the source system to send the data in an Avro file format. Avro is good for write use cases, right? So what you're going to do, get the data in a .avro format from the source, and then we are going to extract only the Avro schema from that source system. So for example, if you go and import the data by using scoop or whatever in an Avro file format, then what we'll be doing, we'll use some program, some jar file that is downloaded from the internet to only extract the .avsc file out of the Avro data. From the Avro data, it will have in the header the JSON data format. So that JSON alone we are going to extract in a name called AVSC. That means Avro schema format. Then we are going to use this Avro schema format to create a table. So we'll keep this Avro schema format schema file in some location. We create a Hive table without defining any column name or data type and all. Rather, we'll use the Avro schema file, which contains all the information derived from the data source data that we received. And then we'll ask Hive to create the table automatically based on the schema. So by that way, what Hive will do, we drop the table and recreate the table, external table in Hive. By that way, what the Hive will do, it will go and maybe refer the schema file and create a table with a new structure. Each and every time when we receive new structure from the source, it will create that structure in our target also and accommodate the data accordingly. So let's go and see that magic of how it is happening. So first we have to do what? Import the data using scoop by in a format of Avro data file format. Why we go for Avro data file format import of data using scoop? That is the first concept we are understanding here. I'm writing scoop in a Hive prompt, which is not supposed to happen, right? I have to run the scoop in a normal prompt. So cust Avro is the location we are going to get the data imported in a Avro file format. First, we are doing this activity. So source is going to give us the data, which is variable in maybe the whatever format where the structure in the source is going to keep change. Let's assume we are going to pull the data from the table called something like customers. Okay, this is the customers is a table which is kept in the cust payments database. Okay, so let's check whether the cust payments database is available or not. That we some time ago created in the top of the use case. This cust payments database we already created. So from that cust payments database, right? If you remember, we have a table called customers table. So this customers table, we first have a format. We have this format. This customer table have a format over here. So we just imported the data as per this format, what the source have provided for the day one. So today is the day one, we imported the data. So in this location, we can see the data imported. So this shows clearly the data is imported, and in the first line of this data, if you see, it has the schema, Avro schema. You can see here, ABSC. Avro schema is kept in this first line of the data, what we received from the source. Now we are going to do what? I wanted that schema alone separately. So for that, what we are going to do? We are going to download from this Maven repository. In this URL, we are going to download a jar file that is being provided by our common repository system. Somebody have provided this. The company called Maven have provided this jar, or people have uploaded their jars into the Java archive file into the Maven repository. What is Maven? We deal about it in a very later point of time. But I'm just importing some jar from that Maven repository, and I'm going to use this jar. I'm going to take this jar into our VM. Somewhere in a location, I'm going to keep this jar, and I'm going to use this jar, whatever I brought, right, which is kept in this location of home HD user. In the home HD user location, I kept this jar. Now I'm going to say what? Hey, use a command called Hadoop jar command. Read this jar file. Use the function called get schema function. and go and read the data from the Avro file what we received from the source. From this Avro file, you extract only the schema out of it, like this we are telling here. So this command will return only that schema, whatever the JSON structure in our platform. So this command is going to take care of generating this JSON file, the schema file. At customer.absc. ABSC means Avro schema file we are deriving. So this contains the proper schema of the table. Now we don't have to. What we are doing here is we are just telling, hey, Avro tools jar, can you help me go and extract only the structure from this file? This file contains data and the structure. Can you get only the structure? That means the schema of the table alone. Can you get, like this? I'm telling. So by this way, what will happen? Our Avro data will provide you the, or this AVC file will contain the schema of the table what we received from the source. By using that schema file, the schema JSON file, first we are going to put this schema JSON file in a Hadoop file system because we need it in a Hadoop location to consume it further. So we are keeping this in a Hadoop location somewhere in a temporary folder. Then we are going to create the Hive table as an external table. If already the table exists, I'm going to drop it. But this is the first time we are going to get this table created. So this is not going to be applicable much of. The second iteration onwards, it is applicable. Let's create a table. This is the first time you are seeing without mentioning the create table name, without mentioning the column name and the data type. We are creating a table here dynamically. We are telling what a create a table stored as Avro data Avro file, and the location is so and so. Point to this location, and mainly look at this table properties what we are using. Avro schema URL, I'm going to mention saying using this Avro schema, what we created, right? What we kept in the Hadoop file system, right? What we derived from the source data, use the schema to create the table like this, I'm telling. So automatically what happens, we don't have to sit and type all the column name data type. Automatically looking into the schema file, the table will be created. You can see the table with this format is created. The customer Avro got created. So you can see automatically the column names and the data type have been came from the Avro schema file, what we derived in the previous step. This Avro schema file that we use to create the table without mentioning the column name and the data type. This is the first time in our lifetime we are seeing how to create a table without mentioning the column name and the data type. By this way, what happens? We can drop the table anytime. We can recreate the table with the new schema what we have. Iteration number 1. That is, first day we are receiving the data from the source. We are going to create a table and load the data. This is the iteration number 1. So we are going to select the data from the table. If you see, there is a phone number column we are having for this customer. Maybe some customer number, let it be anything. Okay, so we created an external table like this, pointing to this location, customer Avro location. So let's check whether the same location we imported the data or not. Customer Avro, Cust Avro. It seems we imported the data in the Cust Avro, but we created the table in customer Avro. So let's load the data from the Cust Avro to the customer Avro. I thought I'm creating the table itself in the same URL. So we got the data in the table now. Here, if you see particularly the phone number that we have over here, there is a column called phone number we have after the contact first name. So this is the phone number of the customer. Now the concept is, now that we are going to understand about, in the source system side, what they are going to do, they are going to change the table. They are going to drop the phone number column for some reason. So they are removing one column and they are adding a new column called mobile. Rather than phone, old telephone, they are going to use mobile phone. They are updating the customer profile as mobile phone, customer table as mobile phone. And if you see here, this new customer table contains only in the MySQL, we have to do this. We're removing a column, we're adding a column, we are updating some value to a column, right? All this activity, we are doing it in the source side. So the second day, what is happening? First day, they provided the data, we got it loaded into our table. Second day, what they are doing, they are changing this table structure. If you see here, this shows no phone number, mobile number is added. Mobile number column is added, phone number got removed. From the in-between column got removed and the new column got added in the last. So we got one column removed, phone number that is after contact first name, phone number was there that got removed. And one more new column called mobile is added. Notice it very carefully. Now we are going to do what? All the step number 1 to 4 we are going to run again. Step number 1 to 4 is all about this one. We are going to again re-import the data, the entire data by using scoop import command. So the source data will be refreshed. The target data, the data for the Hive table will be refreshed. We are going to extract the schema, the new schema from the file by using the maybe Avro tool Java program, the Java jar file we are going to use to extract the schema from this data once again, the new schema. Let's get that done. Once that is completed, the new schema will have the phone number removed and the whatever that maybe mobile number column added. If you see here, it will show the mobile number added in the column list. You can see here. And there is no phone number present at all in this column list. This is the new schema what we received from the source system in the next iteration, the next day run. Right? And then we can go and put this file in the same location where we had put earlier. Now we are good to create or drop and recreate the external table. Let's go and drop the external table and recreate the table and load the data. Now, if we go and select the data from the table with the column called mobile number, with the column called phone, right? The phone column got removed from the table. So it is telling, sorry, there is no phone column present, Irfan. You have only mobile column. So we have to use mobile rather than phone going forward. That means the column got removed in the target table in Hive also, and the new column called mobile added in the target table called Hive also, which is a drastic difference we are making here, right? The mobile number is got created for the customer rather than maybe the, the phone number, we are seeing the mobile number here. The old phone number is becoming invalid here. We don't have the phone number available for this customer going forward. Like this, we got the schema evolved. Since it is an external table, what happened? The existing data is not removed, it seems. So we can do one more thing. We can remove the target location and we can, because we loaded the data from the one location to another location, right? So what happened? This target location where we had the data, this Avro customer Avro location where we have the old data is also showing up. Maybe we can remove this data since we are after dropping the table. Hadoop fs minus rm. This data can be removed. First we can remove and then we can reload, basically. Because of this, it is showing unnecessarily 2 records for the same customer. We don't require that because already we are reloading the data. So drop the table, remove the location, underlying location. Maybe first you do the removal of underlying location, drop the table, create the new table with the new schema that we received, load the data, select the data with the new schema. That is mobile number going forward. The iteration number 2, you do what? Select the column with mobile number. By that way, we can able to see the result. So if the source changes, remove the column or add the new column or change the data type of the column, do anything, right? Whatever they want, we can able to accommodate that without intervening. We don't have to intervene here to change the column data type or anything by altering the table, adding the column, removing of the column and all, nothing we have to do. Automatically that will be taken care if the source have any changes in their schema in the source side. This is called schema evolution. I will tell you one example where we recently applied the schema evolution, right? We are enabling the data for our data science team, right? So let me just quickly conclude what I have did recently in my organization, right? Not recently, so maybe a year ago, 1.5 years ago, like that and all. What I did, I remember the source system will be there, okay, and we are the data engineering team, and data science team will be there. Data science team will be there. The data science team will discuss with the source team. Source team means the business team. Business team or the source team. They'll be discussing. Let me keep the source team itself. They'll discuss with the business, and they'll go and talk to the source system and ask them to enable some of the fields, some of the attributes. So basically, the data science team will go and get few attributes first. We call it as a features. Few attributes or features. Features means some of the vital columns, important columns. Okay, they'll try to get from the source system initially. Few features or attributes request from the source directly on day one. Then what happens? The data engineering team will have the pipeline created for pulling the data from the source system by using Scoop, Hive, or whatever the pipeline, Spark, or whatever the pipeline, and enable the data for the data science team to consume. Then what happens on the day two? Day one, this is going to happen. Day one, it will happen like this. On the day two, what happens? Same thing will happen by the data science team talking to the source system, saying like, hey, we wanted few more attributes or features that is required for our data science iteration to complete. We wanted to build the model and all based on more attributes. So can you start send some more attributes like this? So the data science team, our consumer will directly ask the source system. Source system will start send the new fields to the data engineering team. In this case, what will happen? Data engineering team pipeline will fail saying like what, hey, we are expecting phone number column, but you are not sending the phone number column. One problem is that one. Second problem is you are automatically adding the mobile number column and sending based on the request raised by the data science team. But you guys did not inform us priorly, and these changes are regularly happening on day by day basis. How can we accommodate this? Like this, while we were asking the question, we got a solution of understanding. The Hive supports some concept called schema evolution concept. Why not we can implement this concept to automatically evolve the schema as per the change that is happening in the source? Why not we can evolve this and get it achieved like this? We were getting this strategy created and finally enabled it. So hope this use case will help you to answer in the interview also. With one of the question the interviewer may ask like, tell me some above and beyond above and beyond activity you performed, you recently performed, rather than maybe doing a BAU, business as usual activities like this. If they ask, you can take this as a scenario and explain. Okay, that is the end of our additional use cases, guys. And in addition to that, you can go to our Inceptus page where additional Hive real-time use case for interview and all I have kept here. You can try some of them out as well, which I have documented and provided. But I think something else I have given here also in addition. Schema evolution, everything I kept here. And if you see here, the slowly changing dimension concept, how can we implement in Hive? Using Scoop, I have mentioned here. You guys can try this use case also in addition, right? Automatically, you can understand what we are doing here, right? How do we maintain the history? How do we override the data? All this you can see here. So this one use case, additionally, I have in our web page. So you can go and try this use case to understand how to implement slowly changing dimension using Hive. We have seen earlier the slowly changing dimension using Scoop. You can take this as an opportunity to understand about the slowly changing dimension concept in Hive as well by going through this use case and implement this use case. Apart from that, the dynamic partition management using our shell script and all we already seen. Let's not worry. Only this part alone, you can refer this page. Maybe I can mention that also here in our document for your reference. Try out this topic in the inceptors.in web page. In this URL, you can go and find it out. In this URL, you guys can go and find it out. Maybe I will make it more proper with the proper coloring and all, and share you guys once again this document. Make use of it. Okay. All the best, guys. Try this out and close this Hive with this. Thank you all.